All right, we're going to start Chapter 5, and I'm going to start it a little differently. I'm going to start by going over some code. In a second, I'm going to go over the handouts that I gave you, all right? But before we do that, hopefully you remember this. This is the one that we had been developing in class. This was the console one, but what I want to show you is this. Chapter 5 in your book is on looping. You've already been working with looping. Notice here we tell you to enter the hours worked. All right, and we attempt to convert it. While the hours worked is less than 0 or the hours worked is greater than 84, we keep you stuck in this loop until you put in a number that's between 0 and 84. Does that make sense? All right. When you write a loop, and there's 3 types of loops that we're going to look at in just a minute, but when you write a loop, you are telling the user that you want code to repeat again and again and again. So imagine a payroll program if you had 10,000 employees. I don't want to sit there and input the stuff for employee 1 and then type in some code, then input 2, then type in the same code, then input 3, then type in the same code. That wouldn't make much sense. It's not that I couldn't do it. It just wouldn't make much sense to do it. All right, this is one of the 3 looping constructs. We'll look at this one and the other ones in just a minute, but it's a while loop. All right, now if we come in here and it says, please enter hours worked, and I put in a 40. All right, well, is hours worked, is 40 less than 0? No. Is 40 greater than 84? No. So this kind of loop is called a pretest. If this test fails, you never go into the body of the loop. You just jump down to what's after it. So if I run this program and I put in 40 for hours, it never does this. Then it asks me for the rate. And if I put in a rate between 0 and 100, it skips this. So again, just to show you what I mean, and I think you get it, but so hours worked, if I put something out of range, so if I put 100 in there, error, it tells me to do it again. If I put something out of range on the other end, same thing. But as soon as I put in a value that's between 0 and 84, now it asks me for the hourly rate. In there, once if I put in a value that's out of range, it's going to give me an error. But as soon as I put in a value that's within range, boom, I get my information. Now, hopefully that makes sense to you. One place we have not looked at this is, what if I wanted to just keep running this program over and over and over and over again? All right? I could literally come up to the beginning here and I could type in this, while 1 equal 1, which kind of looks weird, but we'll go over exactly what that means in just a second. I'm going to take all this stuff and I'm going to tab it over so it looks a little bit nicer. All right. Well, while 1 equal 1, well, as far as I know, 1 always equals 1. So I'm putting this program into what's called an infinite loop, which means I don't want it to stop. But you'll notice the difference now when I run this. And I'm not going to worry about testing it for bad values. I'm just going to put in stuff that is correct. Okay, it puts it in. Now what happens? It starts it all over again. Get the idea? So that's another thing that you can do with loops. When you take your test on chapters 3, 4, and 5 next week, I will ask you to write a console program that you can run repeatedly. You run it repeatedly by putting it into a loop. Does that make sense? All right. Now the problem with this, as it currently exists, is it's going to keep running until I click the X up here. Okay? All right. Now, if you look at the handouts I gave you, One of them is on one page. One of them has got a front and a back. I want you to open up the one that's got or look at the one that's got a front and a back to it. All right? It is, it's a stupid name, but it's called Loops and Loops. All right? Because what I want to show you here is all three of the different types of loops that you can use when you run a program. All right? So there's three types of loops. And again, you're going to see this in just a couple minutes when we go over the chapter, but I decided to show you this in code first. The three loops are a while loop, a for loop, and a do while loop. All right? Those will make their way onto your Chapter 5 test, asking you the three types of loops there are. All right? So let's look at them in turn. All right. What I want to do here is I want to print out the numbers from 1 to 10. So I want this to say the value of LCV, which is loop control variable, is 1, is 2, is 3, is 4, is 5, is 6, is 7, is 8, is 9. Then finally, the value of LCV is 10. Does that make sense? And I want to do it without having to write a lot of code. And you notice I'm not writing a lot of code. And then when I get all the way done, I want it to give me the value of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. If you care, it's 55. All right? But the idea is I want to write this where I don't have to be repeating code. So when you work with any of these three types of loops, a while loop, a for loop, or a do while loop, any of them, they all involve three steps. Step 1, you've got to initialize. I got loop initialization, but it's really, I call mine LCV, which stands for loop control variable. It's the variable that controls the loop. All right? So I'm initializing my loop control variable right there to 1. Then the second step is you have to test. I may have even asked you this before, or I may have asked you this last semester. Please look on the screen here. If I make this 11, is that test going to succeed or fail? I'm asking you the question. If I make that 11, is this test going to succeed or fail? Fail. So in other words, a while loop is called a pretest because you make the check before you get into the body of the loop. The body of the loop is what exists between the curly braces. If the test fails, you skip the loop body. So if I do this, watch what happens. I initialized it to 0. So it says the value is 0. It's not doing very much. But the point is, the reason that it didn't do much here is because I told it not to do much by setting my loop control variable to something that was illegal. All right? And when I say illegal, I mean illegal in the sense that it's going to fail the test. But bringing it back here, this should make sense to you now. This is just going to say while loop example. So what is this doing? That code that you see in there is doing this, and it's doing this. It's exactly what it's doing. So if I make the change, run the program again, that shouldn't be any kind of surprise to any of you. All right, so when you want lines of code to repeat, one way you can do it is with a while loop, and the while loop is known as a pretest, and the variable that you use to control how many times you go through the loop is known as the loop control variable. All right? And you'll notice with this loop we have what? 1, 2, 3, 4, 5, 6 lines. All right? Totally fine. We have 6 lines there. Now, I'm going to come in and I'm going to comment out. I want to comment out all that stuff we just did. Why? So I can show you the second type of loop. Remember, this had 1, 2, 3, 4, 5, 6 lines of code in it. And it actually had more than that. 7 lines, because we had to initialize our variable. When you use a for loop, you do all 3 things on the same line. So instead of having 7 lines of code, we have 1, 2, 3, 4, 5 lines of code. When you write a for loop, you write less code than when you write a while loop, because you're doing the initialization, the test, and the increment or decrement all on the same line. None of these are mandatory. Just so you know, none of them are mandatory. All right? Now, if I did this, I'm not going to because it would be unbelievably stupid. But if I did that, that would literally say run this loop forever. That is another way of setting up an infinite loop. The problem is it would come in here and it would say, okay, well, we haven't added, we don't have that LCV anymore because we removed it. All right, so we're going to get an error because it doesn't know how to use that. The point is, though, had there been no errors, this would have ran forever. Some of you have heard me say this before, and some of you new people maybe have not, but before I got into education, I worked as a programmer for AT&T Bell Labs. That was back in the day when you had the old rotary phones. You picked it up and you got a dial tone. All right? That code that made that work, so when you picked it up and got a dial tone, that was in an infinite loop. You wanted to be able to get a dial tone 24/7. All right? So if you've got code that has to constantly be running, you can put it into an infinite loop. All right? We don't want that. We want this. So this is our initialization. We're creating a brand new variable called LCV2. It's of type integer, and it's got an initial value of 1. So as long as that value is less than or equal to 10, do this stuff, and every time you get down to the bottom, add 1 to it, check it, and if it's still less than 10, do it again. So what you're going to see in this case looks a lot like the other one, but the other one said while loop example. The value was exactly the same, and the other one said the value of while sum is 55. So they work the same. They're both pretest loops. They both use a loop control variable, or LCV. All right? And they both pretty much work the same. Now, the for loop is called a counting loop, because when you run a for loop, you need to know exactly how many times you're going through it. All right? Anything that you do with a for loop, anything you can do with a while loop. The reverse is not true. You can do things with a while loop when you don't know how many you have, but you can't do that with a for loop. All right? So I'm going to comment this out. All right, now I'm going to look at the last type of loop. The last type of loop is known as a do-while loop. There's some goofy stuff about this loop. If you look up on the screen here, you put the word do, and then it pretty much looks the same way that the while loop looked, but you put the while at the end. Also, and that's not an error, this is the only time you put a semicolon at the end of a loop, or at the end of an if, or at the end of a switch. The only time you do that is in a do-while loop. All right? The other 2 loops I showed you were pretest loops. And I told you, when we looked at this one, I made that 11 there, and it didn't go in here. If I'd have come in here for this for loop, and if I'd said it equals 11 right there, if we did that, it would never have gone into the body. However, when you work with a do-while loop, you don't test it till the bottom. So even if this is illegal, even if I'd made this 77, watch what happens when I make that 77. It always runs through the body of the loop at least 1 time because it doesn't test it until the end of the loop. So whereas a while loop and a for loop are known as pretest loops, the do while loop is known as a post-test loop. Does that make sense? All right. The other thing that I wanted to show you, and this is, believe me, this is not like, oh, wow, unbelievably cool. But the other thing is, if you look at the other handout that I gave you, it's a single page. And what it shows you in here is you can have a loop within a loop. And that's exactly what we have here. When you look at it, the program starts basically on line 8. Well, I guess it does start on line 1. But it's 37 lines of code. And what it does, it's easier to run it for you. It simulates a clock. If you look, so it's going through from midnight military time all the way till 11:59:59. Now, the computer was done in less than a second. It's the output that takes a while to print. All right? And it's really not that bad. It'll speed up. Okay? But that's what takes the time. Still, what did it take to print that out? 30 seconds, maybe? All right? But what did that do? Well, it went through 3 loops. The outside loop or outer loop said go from 0 to 23. All right? Then this loop here said go from 0 to 59. This one said go from 0 to 59. And you'll notice there's no code inside of this for loop except another for loop. There's no code inside of this for loop, all right, except another for loop. But there is code in this for loop. This is the code that prints everything out. And notice I put in here D2. So if it's 0, it'll print a leading 0. So for midnight, for example, it's 000000. Okay? So what this does is it simulates a clock. We start out with 0 hours, 0 minutes, and 0 seconds. Then we have 0 hours, 0 minutes, 1 second, 0 hours, 0 minutes, 2 seconds, until this gets to 59. Then we have 0 hours, 1 minute, 0 seconds. And then it keeps going until my minutes are at 59 and my seconds are at 59. Then it goes to 1, 0, 0. If you can understand that, you understand the concept of nested loops. A nested loop is a loop within a loop. That's all it is. And loops are nice because they can result in a lot less code, and they can make your life a hell of a lot easier. Oh, that's nice. So, if you got your book, you might want to open it up. So this is Chapter 5. In Chapter 5, we are on page 137. Again, talking about making decisions. Let's go till about 9:15, and we'll take a break, come back from the break, and we'll finish this up. And we'll look at some code. Oh, you're right, Chapter 4, not Chapter. You're right, we want to go to Chapter 5. Thank you. $190, thank you. All right. So, what do we want to do in here? Well, take a look at those first 3 objectives. I just showed them to you. I showed you a while statement or while loop, a for, and a do. You saw all those. I showed you nested loops. I even showed you an accumulator. That was this. All right. We'll talk about how you can improve loop performance and problems that you can have. It's much easier to write non-GUI programs with loops. It's much harder to write GUI programs with loops because GUI programs with loops are totally under the control of the person running the program. whereas console programs are more under the control of the programmer. All right? So, a loop is code that can potentially repeat. All right? If you've got more than one line of code that you want to put into a loop, just like with an if, you must put it in parentheses. Each time you go through a loop, every time you go through it, like when we went through it 10 times, each one of those is known as an iteration. So it says here with a while loop, you already saw this. It has the keyword while. Make sure you use a lowercase w, all lowercase. What you put in the parentheses is a Boolean expression. You already know what Boolean is. I've asked you several times. It's something that must be true or false. So while your loop control variable is less than or equal to 10. If it is, you go into the loop body. Once it's not, you get out of the loop body. All right? If you forget to put something in to get out of the loop, you get what's called an infinite loop. This is on the test. So if you look right here, if I did this, notice here we're adding 1. If I took that line and commented it out, what would happen is it would print in here, the value of LCV is 1, 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 forever. That is an infinite loop. If that happens in a console program, you want to click that X to get out of the console. If it happens in a GUI program, all right, you just stop the run. You click the little red triangle that appears over here. All right? Most of the time when that happens, an infinite loop, if especially when you're starting the program, it's because of programmer error. All right, it's a logic error because you didn't remember to put in something to change the value of your loop control variable. So I call my loop control variables LCV. By no means do you have to. This is considered the only time in programming where it's okay. Let's say I've got 3 loop control variables. Calling them something like I, J, and K, that's considered acceptable. That's the only time that you should, that you can have, for lack of better words, kind of a piss poor name for your variables. All right? I didn't like most of the examples that she put in here. That's why I just wrote my own. All right. If you've got a loop that's got nothing inside of it, so in other words, if I had said something like this, don't ask me why I would, but if I wrote something like while LCV less than or equal to 10, and all I put inside of there were just curly braces, nothing else, that's called an empty body. There's nothing inside of there. For right now, there would never be a reason that I can think of in what we're doing that you'd want to do that. All right? When you change the value of a loop control variable, you either increment it or you decrement it. Please again look up on the screen. I want to show you a couple things here. All right, I'm going to go back to the program, the one that was called Loops and Loops and Loops. I want to just show you quickly 2 things. First thing, all right, there's nothing that says here that I've got to add 1 to it. There's nothing that says I got to do that. What if I did this? LCV plus equals 2. All right, now notice what happens. See that? It was 1, I said add 2 to it. So it's 3, I said add 2 to it. So it's 5, I said add 2 to it. It's 7, add 2 to it. It's 9, add 2 to it. You get out of the loop. So you don't have to necessarily change the value of the loop control variable by 1. Most times you do, but you don't have to. So if I told you to write a program where that you printed out, and I'm not going to, but I said print out all the even numbers between 0 and 500. you could do that. All right. Again, all you'd have to do you'd set that to 0, and you'd say while that's less than or equal to 500. All right, there'll be quite a bit of output, but you'll see it. Okay, and I can scroll back up and see most of it. I guess I can see all of it. Does that make sense? All right. What if I don't want to do this? What if I want to go in the other direction? Okay, so in other words, what if I want to set my loop control variable to 500, and I want to get out when it's less than or equal to 0. Then I have to make sure that instead of adding, I subtract. All right, so notice what happens now. Oops, well, something was screwed up. It would have to be greater than or equal to 0, not less than or equal to 0, and that's why it blew up. So there's all of my odd numbers going backwards. So you can take a loop control variable and increment it by 1 or more, or decrement it by 1 or more. Does that make sense? You will definitely be using some kind of loop in your next test. And probably 2 different kinds of loops. All right, probably one that I'll have you use on the console one and one on the GUI one. You are going to do one of each again. All right. When you know exactly how many times you're going through a loop, you know, how many times, how many iterations, how many times you go through a loop, it's called a definite loop or a counting loop. Why am I asking you that? Because definite loop and indefinite loop, I think they're both on the test, on the written test. So a definite loop, boom, you know how many times, definitely you know how many times you're going through it. With an indefinite loop, you don't. And sometimes that confuses people. Well, why would you ever use an indefinite loop? Well, imagine that I work at a company where somebody gives me a list and says, let's say I work at a bank, and somebody gives me a list and says, hey, here's all the deposits for today. We need to find out how much money was deposited here. And they throw it at me. How many are there? I don't know. I couldn't use a for loop unless I counted first to see how many deposits there were. But I could use a while loop or a do while loop. And instead of saying, do this, all right, do this while number is something like that, I'd say do this while I still have deposits. All right, so it would be done a little bit differently. All right. Sometimes you do something like this. Do you want to see your balance? All right, the other day I stopped. It's the first time I ever took out money at a Schnucks. All right, so I'm in Schnucks, and a lot of times, you know, what happens is it'll ask you at the beginning, do you want to see your balance? You know, when you print it out, and I always say yes, because then I get really depressed. All right, but there it just came in and it asked me if I wanted to, you know, what I wanted to do. I took out $100, and it gave me my receipt. Then it came back, but that one kept my card, and it said, do you want to see your balance? And if I said no, because that would have given me another receipt. You see what I'm saying? But when it said, do you want to see your balance, it's something like that. That's called a sentinel value. All right? Maybe you watched old episodes of old Army movies, or maybe MASH, where you saw somebody say, halt, who goes there? That's a sentinel. Well, the sentinel here, sometimes what you do is you use something that doesn't make sense. In other words, if I said, write a program that would allow you to keep entering test scores that must be between 0 and 100. However, if you enter a test score of minus 999, stop doing your inputs. Does that make sense? That minus 999 would be a sentinel value. I believe that's on a test. All right. right, with a for loop, as it says, you can put all three things in there, just so you know. So this while loop that they show right here in all this blue, that, including these two lines here, but all this, that is done with just two lines in a for loop. Now, if it is easier for you to understand using a while loop as opposed to a for, then do that. Most people like the for loop because it results in less code. All right? But again, anything you do with a for loop, anything, you can do with a while loop. A for loop is one of those definite loops. It's a counting loop. You need to know exactly how many times you're going through it. In fact, this value right here, this value, where here we're adding 1 to it, that's called the step value. All right? They give you a bunch of examples in here. Okay? But I do want to mention this out of scope. I want you to understand this. All right? You're going to hear this in other classes. You're going to hear this with other languages. Okay? If you look, please look up on the screen here. If you notice in this middle example, I know it's commented out, but that's fine. Notice it here. What I want you to understand is on this line here, line 41, we are creating a brand new variable right here. Does that make sense to everybody? That variable begins life right here. As soon as it hits that curly brace and it falls out, that variable is dead. So I cannot use the variable LCV2 outside of this. I cannot do that. You notice it's not in there. If I wanted to use that variable LCV2 in here someplace, I have to define it outside of the loop. Does that make sense? That says that the scope of this variable is within those curly braces. So when they talk about scope in the book, on whatever page this is, page 200, that's exactly what they're talking about. Something being in scope or going out of scope. All right? All right, remember that with the while loop and the for loop, they're pretests, so you check at the beginning. With a do while loop, it's at the bottom. Sometimes, I've had people ask me this question before. Why the hell would you ever use one of these? All right? And I will tell you exactly how I use them, okay? And I think I mentioned this to you before. What you're going to see as we go into more and more and write more and more complex coding, that much of the code that you write is defensive code. It's error checking code, okay? And error checking code, I think I've mentioned this to you already in this class, is like car insurance. You've got to have it, but you hope you never need to use it, all right? With what you can do with a do while is you can put your error checking code in here. Then you're sure no matter what, it'll run. And then you can test it. So sometimes what I'll do is if I want to make sure some code runs, I'll put it in a do while loop. Once I test it and I know it works, I'll reverse it and put it in a regular while loop. There's not a problem with using do while loops. Some people prefer them to while loops. All right? Do you all get what pretest and post-test mean? It's on the test. It's on your written test. Pretest means you check to make sure before you go into the body of the loop. Post-test you don't check until you've already run the body of the loop. A nested loop is a loop within a loop. Guess what? You've already seen that. That was the clock program where you had a loop within a loop. You can nest anything. So in these two loops that you see right here, all right, this is called the outer loop. This one is called the inner loop. Why? Because that's outside and that's inside. All right? Sometimes writing a series of for loops like that is a very fast way to go through this. So what's this doing? It says you're in year 1, so it figures out your different balances. You're in year 2, it figures out except I don't know, maybe I'm wrong. But okay, it's got a different rates. So at 4% for 5 years, add 6% for 5 years, add 8% for 5 years. You can tell this is an old book because I don't know what you can do today where you get 8% back. All right? It's not a bad program in here that they have that starts, I don't know, around page 20 something, 206 I think it is, or 207. It's a tipping program, you know, how you would write tips. All right? I talked about what an accumulator is already, correct? All right, again, that thing was an accumulator. And not to be funny, an accumulator accumulates. All right? So how do you improve loop performance? Okay, please look up on the screen. This is really important, all right? Okay, I'm going to show you something we're not going to get to, you know, for a couple weeks or so. But I just want you to see this. All right, you're going to learn how to create arrays. You don't have to worry about what they are right now. You don't have to worry about them, all right? But if I do this, if I type in here for int LCV equals 0, LCV, oh boy, LCV less than, I'm going to create an array here. Again, don't worry about what an array is. Int, bracket, bracket, numbers equals new int 25. All right, that's going to allow us to add 25 numbers, or put 25 numbers into something. All right. All right. Equal numbers dot length plus plus LCV. Oops. All right. What I'm trying to show you is this. What if this thing was really huge? What if this was 1 million? That would allow us to put in 1 million numbers. Does that make sense? All right. The point is, every single time, 1 million times, the computer has to figure out what's the length of that. And if you say, I don't get it, what if I did this? Int len for length equals numbers dot length. That's going to figure out once, and it's going to give that a value of 1 million. Now if I do this and put in here len, now the program only has to figure it out once. Do you understand the difference? All right. I'm doing the calculation up above, but if you do a calculation in here, the system has to do that calculation once every time the loop iterates or goes through another iteration. You don't want to do that. There's a word for that, and it's dumb. You shouldn't do that. You shouldn't make, you know, even though it only takes a few, probably less than a second, you're still wasting the server's time. All right. The other thing is, again, if you look up on the screen here, remember you can say LCV equals LCV plus 1, which is the worst way to do that, but you can. Or you can say LCV plus equals 1, which is a little better. Or you can say LCV plus plus, or you can say plus plus LCV. I put that one last. That's the one I want you to use all the time, because internally that breaks down to its machine language equivalent of zeros and ones faster than any of the other ones. If you're going to learn to do something, you might as well learn to do it right. All right? All right, so make sure you avoid any unnecessary complications. I told you that. Consider the evaluation of short circuit operators. All right? May or may not make any sense. So let's take a look at it. All right? Notice we got a while in here that says, while requested number is greater than 15 or requested number is less than 1. Requested number, we don't know what it is. We don't care what it is. But it's supposed to be a number you put in between 1 and 15. Okay? So chances are much better you'll fat finger and you'll put in a number bigger than 15, than there is that you'll put in a number that's 0 or less. I mean, if it was less, you'd have to put in a minus sign, correct? So what they're saying here is whatever test would happen more often, put that test first in an OR. And if you're still confused, look at it this way. What if I was testing, to see if you were a freshman, a sophomore, a junior, or a senior in a 4-year college? Okay? And let's assume that 50% of the people in that college are freshmen. Then the first thing I should check is whether or not you're a freshman. Does that make sense? The thing that should happen the most often is the thing that should be checked first. All right? Part of my job in here is to not just teach you how to do this stuff, but to teach you what's best. And that's one of those what's best moments. All right? Loop fusion. Okay? What they're saying in here is rather than writing 2 loops, like they show this in here, why not write 1 loop and call that twice? All right? This is going to execute much faster than this will. Again, there's always a good way to do things. All right? I mentioned use the prefix. Don't use x plus plus. Use plus plus x. All right? Like that. Looping issues in GUI programs. Let me just finish this. So looping issues in GUI programs. Well, that would look pretty ugly on the screen, wouldn't it? Not only that, if I was doing it 100 times, it wouldn't even fit on my screen. So a lot of times when you're doing loop output, that's again where you're going to use that message box that we've looked at. You all know how to build a message box now, as opposed to having a big label with a bunch of stuff on your screen. It doesn't make a lot of sense. All right, good news is we finished the chapter. All right, it is 9:18. Let's come back. Let's make it 9:30. How about 15 minutes? 9:33, please, and we'll pick it up from there. All right, let's go through these review questions. Okay, number 1, a structure that allows repeated execution of a block of statements is known as, hopefully that makes sense. Number 1 is C, loop. It's a loop. Number 2, the body of a while statement can consist of, the answer is C, either a single statement or a block of statements. So number 1 is C and number 2 is C. Number 3, a loop that never ends is called an infinite loop. 3 is D. 4, which of the following is not required of a loop control variable in a correctly working loop? The answer is A, that it be reset to the initial value when the loop ends. Number 5, a loop with an empty body contains no B statements. So number 5 is B. Number 6, a loop for which you do not know the number of iterations is known as B, an indefinite loop. So 6 is B. So the first page here, it's C, C, D, A, B, B. Number 7, which is a major advantage of using a for loop as opposed to a while loop? The answer is D. The loop control variable is initialized, tested, and altered in one place. Number 8, a for loop statement must contain A, 2 semicolons. Number 9, in a for statement, the section before the first semicolon executes once. Number 9 is A. Number 10, the first 3 sections of the for loop are the 3 sections of a for loop are most commonly used for B, initializing, testing, and incrementing. So 10 is B. 11, which loop is most convenient to use if the loop body must always execute at least one time? The answer is A, the do loop. It's also the answer for 12. The loop control variable is checked at the bottom in which kind of loop? The answer, I'm sorry, that one is 12 is B, the do loop. 13, a for loop is an example of a B pretest. 13 is B pretest. 14, a while loop is also an example of B, a pretest. Number 15, when a loop is placed within another loop, the loops are said to be C, nested. Number 16, what does the following code segment display? As far as I could tell, it would be B1. Why? Because there's a semicolon after this while loop. All right, what is the output of this? I think this is wrong. Okay, S is 1, so it says while this plus S, right? Everybody agree with that? So this should add 1 to S. To me, what it should print here is 2. There is not one on here that says 2. I think this is a bad question. Number 18, what's the output of this code segment? As far as I could tell, it was C. 5, 4, 3, 2, 1. Number 19, what does the following code segment display? The answer would be 0. Why? Because now they have a semicolon at the end of the for loop. Finally, number 20, what does the following code segment display? I got C, 0, 1, 2. 0, 1, 2. All right? Now, the next thing are the exercises. The exercises, some of you were not here yesterday. All right? You know who you are. It's fine. But if you weren't here yesterday, just so you know, what I assigned for yesterday, you want to go back to page 185. I assigned numbers 3, 4, 5, 6, and the debugs. All right, so on pages 185 to 187, number 3, number 4, number 5, number 6, and the debugs on page 187. For this chapter, if you turn back then to 224, for this chapter, I'm going to ask that you do number 2, number 6, number 8, number 11, and the debugs. 2, 6, 8, 11 on pages 224 and 225, and the debugs. Everybody clear on all that? All right. Last thing before we go back and look at some code.